Okay, in section 5 we're going to talk about the graphs of the sine and cosine function. So we've looked at sine and cosine as ratios of right triangles, but what we're going to try to do now is try to have them be graphs on the xy plane. How we typically do that is for the x value of this thing, we'll typically call these different angles. So we'll pick a bunch of angles, and then y is going to be our trig value. So it could be the sine of the angle, cosine of the angle, whatever. So the first one we're going to try to graph is f of x equals sine x, which of course is the same as y equals sine of x. So we want to see what happens to this when it's not a unit circle function, but when it's actually a function on the xy plane. So to graph it, I'm just going to do traditional graphing where I pick some x's and find some y's. So I'm going to pick some key points of this angle, and you'll probably see why these are important based on your unit circle. So I'm going to pick 0 degrees, or 0 radians. I'm going to pick pi over 2 radians, remember which is 90 degrees. We typically do it in radians, not that you have to. I'm going to pick pi radians. I'm going to pick 3 pi over 2 radians and 2 pi radians. Because what you'll see is there's a really nice pattern to these values. So if I look on the unit circle and I want to know what the sine of 0 is, I go to 0 radians, I look what the y coordinate is, and it's 0. I look for what the sine of pi over 2 is, so I go to the pi over 2 on the unit circle, and I know the sine is 1. And I continue this, the sine of pi is 0, the sine of 3 pi over 2 is negative 1, and the sine of 2 pi is back at 0. So these are what we call key points, and the reason that we use these, because there's lots of points we could use, we use these points because you notice the y values are all really nice. They're 0, 1, and negative 1, all really nice values. So if I'm going to graph this, I'm going to come over to my xy plane here, and what you'll notice is these are going to be angles on the x-axis, and the y-axis is going to be sine of these angles, sine of x. So my first point is 0, 0. So you'll notice this axis is in terms of pi. So 0, 0, so I have a point right here. The next point says pi over 2, which is right here. The next part is pi 0, which is right there. The next is 3 pi over 2, negative 1, which is right there. And the next is 2 pi, which is right there. 2 pi 0. So what you'll notice, if you connect these with a smooth curve, you get kind of a wave. This is what the graph of sine of x looks like. And the cool thing is, it actually will repeat itself as you go on. So if I go to the next increment of pi over 2, which would be 5 over 2, it'll go back up. And then if I go to the next one, it'll go back down. And I could go the opposite way as well. So I could go this way as well. So this big thing is basically this big repeating wave that repeats over and over. Now the neat thing is, this part of the graph is one part of the graph, and then it will repeat itself over and over and over again. Now some kind of neat parts about this graph. The domain of the sine function, domain meaning how far does it go on, it goes on forever. So the domain of the function will go as big or as small as you want, so we'll say it's all real numbers. And all that means is it's going to go as far left and as far right as you want. It's going to keep repeating over and over and over again. What is the maximum value of y? Well, the tallest value of y, you'll notice, is here, and here, at 1, but it happens lots of times because you have all these peaks as it keeps repeating. So the maximum value is 1. The minimum value is down here and down here in lots of other places. That's at -1. So the range is basically what numbers does the graph go between? Well, it goes between -1 and 1. So it's all the values because of -1 and 1. All those values in between are the range. Now another neat term that we use a lot in these graphs is what's called periodic. It's periodic because the y values will repeat. You notice the graph repeats. So what's the period of sine? The period of sine is 2 pi. That means this is going to repeat every 2 pi. From 0 to 2 pi, we get what the graph looks like. This is one period. And then I could see it again and again, and the period repeats every time. So every 2 pi, you get another one of these kind of waves where it goes up and then down and then up again. So a couple other interesting things to this. You'll notice the sine is what we call an odd function because it is symmetric to the origin. Kind of a geometric term you may remember. Not that big a deal. What are the x-intercepts of the graph? Well, there are lots of x-intercepts for the graph. X-intercepts obviously where it crosses the x-axis. I see one there, and there, and there, and there, and there. So at 0, 1 pi, 2 pi, 3 pi, 4 pi. So really it's basically every multiple of pi. So we'll say multiples of pi. Any multiple of pi is a x-intercept. Now the y-intercept, there's only one of those because where it crosses the y-axis, only one spot, it only crosses right there at the origin. So that's the only y-intercept, or only, y-intercept. So 0, 0. So the picture of the graph is good, and we can of course graph this on Desmos, as you see I've done below. But some of these properties are kind of neat ones to think about as we go forward. So here's what this looks like on Desmos. Now all I did in Desmos is I just put in y equals sine x to the grapher. But you'll notice that I have these increments on my graph that have pi over 2 and negative pi, which is kind of what we want for these. So what I did is I went to the little wrench. So let me try to draw my wrench here. And then I went to what's called x step. There's something that's called x step on there, and I just simply typed in pi over 2. So if you type pi over 2 into your x step in your settings for Desmos, you'll get this nice graph like I have. And again, you can see how the graph follows, starts at 0, goes up, goes down. Going to go both directions. So let's look at the cosine function, which really is basically the same thing. It's just going to be looking a little different. So first thing I'll do is I'll get those same points as I did before. I'll use 0, I'll use pi over 2, I'll use pi, I'll use 3 pi over 2, and I'll use 2 pi. And then what I'll do is I'll find the cosine of those x values for my y values. So the cosine of 0, according to my unit circle, so I go to 0 radians, and it's the x coordinate, so it's 1. And then it would be 0, and then it would be -1, and then it would be 0, and then it would be 1. So it's essentially the same numbers, just in a slightly different order. So I'm going to try to graph those points over here on my axis. So the first one says 0, 1. So there's a point right there. Then it says pi over 2, 0. So everything's repeating in the same kind of thing. Pi -1. 3 pi over 2, 1. Or, excuse me. 3 pi over 2 and 0. And then we're over to 2 pi back at 1. So those are my points. Now if you plot it, it doesn't really look like a kind of wave like the first one did, but it actually is, because if I connect the dots like we did before, something like this, but the key thing is it's going to repeat itself like a sine did. So it'll go back down to there, and then back down to there, and then up to here, and then back up to here. So if I do another period of it, it looks something like this. So same idea as sine, it repeats itself every 2 pi. Every 2 pi I get a period, what we call one period. Now a lot of this stuff is very similar to the sine function as far as these properties. We'll just run through these real quick. What is the domain of the cosine function? Well, again, it will keep going forever and ever in both directions. So we say all real numbers. The maximum value of the cosine function is going to be 1 because that's the highest it goes. The smallest will be -1, just like the other one. So the range is going to be all numbers between -1 and 1. It is periodic, it'll repeat itself, so it'll repeat itself every 2 pi. And cosine is what we call an even function because it's symmetric to the y-axis. So if I continue this graph, basically if I folded it over the y-axis, it would fit perfectly. X-intercepts, you'll notice they're at pi over 2, 3 pi over 2, 5 pi over 2. So basically it is odd multiples of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2. And the y-intercept is just the one y-intercept here at 0, 1. So it looks just like the sine function except for it's kind of pushed over to the side. But the good news is here is our nice Desmos graph that again I just put in y equals cosine this time to get this graph. Y equals cosine of x. And you can see there's my intercept and there's my periodic function. And it will continue forever and ever and ever. So what we looked at so far is we've just kind of looked at a general sine and cosine function. But lots of different things in our world, especially like sound waves and light waves, can kind of be modeled with sine and cosine functions. But they're obviously not the generic ones that we just saw before. So we can actually change these different sine functions into different ones that repeat more often. So instead of our general sine, they can repeat more often, something like this. We could make them go longer up and down, something like this. We can change those things just by changing our equation. So the two things we'll do is amplitude and period. So the amplitude basically is how high and how low our graph is going to go. So if I look at a generic sine or cosine function, let's do sine. We know that the amplitude of a regular sine is 1. It only goes up to 1. But if I put a number in front of here, say I put a 6 in front of here, well, the amplitude is always going to be the absolute value of this number in front. So the amplitude is going to be the absolute value of 6, which is just simply 6. So this graph would go up or down to wherever you want. So if you think of an amplitude, you've probably heard of an amplifier in music. So the amplitude is basically the intensity of your sound, how loud it's going to be. So that's the amplitude of our sound. So it's the intensity of the sound. Now the period, which we said in a normal cosine function is going to be just 2 pi, we can actually change the period of any kind of cosine or sine function by just simply putting a number here in front of x. So I put a b there or a b there. If we put a b there, we can make the graph get smaller or wider just by simply getting in a new period. And the new period is given by this formula right here. It is 2 pi over b. And the period is going to be related to the wavelength of our sound wave. So you know what a wavelength is. That's what will be related. Also could be sometimes called the frequency. When you turn in on your radio to whatever station you're going 97.1, that's a frequency. which is related to this period. So let's look at a couple examples, and then we'll see how we can graph them with new periods and amplitudes. So again, I'm just going to write a generic formula down here. So y equals sine bx. If that's our function, then remember the amplitude is the absolute value of a. The period is 2 pi over b. So the amplitude is going to be the number in front. So for this first one, the amplitude is simply going to be the absolute value of 2, which is 2. Now the period, there's no number in front of the x, so it's essentially 2 pi divided by 1, which is 2 pi. So that means this function is going to repeat every 2 pi. The amplitude of the second one is the absolute value of -3, the number in front, so the amplitude's 3. That means it'll go up and down to a unit of 3. Now, 4 is the number in front of x, so the period will be 2 pi over 4. 2 fourths reduces to 1/2, so this is pi over 2. So this thing will repeat really quickly. It repeats every pi over 2. So it's a shorter period, so it kind of gets condensed. So instead of being like this, it'll get condensed and repeat more often. Okay, the amplitude of the last one here has a 1/2 in front, so that's 1/2 because it's already positive. Now the number in front of x in this case is 2 pi, so the period is going to be 2 pi over 2 pi, which is simply 1. So all of these have had a period with a pi in it, but if you put a pi in front of that x, you can make a period that doesn't have any pi's in it. So let's look how we could graph some of these. So I'm going to graph y equals cosine x. We just did this on the last page. We know it has a period of... So if I pick some values, I'm going to pick the same ones. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm simply going to use my calculator to figure out what these values are. So I'm going to plug these things in. So if I plug in 0, I'll get 2 cosine of 0. So if I put that in our calculator, I'll get 2. So our first point is 2. For pi over 2, I'll do 2 cosine of pi over 2. That's 2 times 0, so that's 0. And again, these are just values you find in your calculator. 2 cosine of pi is going to be -2. 2 cosine 3 pi over 2 is going to be 0. And 2 cosine of 2 pi will give me -2, or positive 2. So 0 and 2. So when I go over to graph it, 0, 2 is going to be here. Pi over 2, 0 is going to be here. Pi -2 is here. 3 pi over 2, 0 is here. And 2 pi 2 is here. So what you'll notice is we get this graph, which will repeat itself then, going both directions. So you get this thing that's much taller. So instead of going up to 1 and -1, you'll notice it goes up to 2 and -2. And that's directly related to the fact that I changed its amplitude. Okay, let's look at one more question. And this one's going to be a little trickier because it has a different period. We did this one on the previous page as well. So remember the amplitude of this one was 3, and the period was pi over 2. So the problem with this one is it's going to repeat a lot faster. So when I do my table of values, I start with 0, that's always fine, but instead of going all the way to 2 pi, I only want to go as far as the period. So whatever that last period number is, I want to put in that last box. And now for the other ones, I can put any number I want that's smaller than pi over 2, but I'm just going to basically cut it in half. So if I have half a pi I cut in half, I get pi over 4. And then I could do anything else I wanted, so I could say, all right, between 0 and 4 would be pi over 8. And between these, this would be 3 pi over 8. Now again, I just found basically the middle of these numbers. But you could really pick any numbers you want to graph it. And then to save ourselves some time, I'll just figure out what these are. So this is 0. This one is going to be -3. This will be 0. This will be 3. And this will be 0 again. Now again, I made this nice table, but you know, for where we are, you can simply just graph this on Desmos and also see all these points. So if I graph these, you'll notice there's no axis here, so I have to label these myself this time. And I did that intentionally because I knew it wouldn't be pi over 2. So maybe I'll call this pi over 8 right here, and this pi over 4, and this 3 pi over 8, and this pi over 2. So we'll start at 0, 0. The next one, pi over 8, we go down to -3, so way down there. Then up to pi over 4, 0, way up to 3, and then back down here. So you'll see a couple things. It's much taller, it's much narrower, it's also upside down. And that's basically because of the negative. So if I repeat myself, it looks like this. So go ahead and practice, try graphing some of these. Obviously use your Desmos to make sure you get the graph right and just kind of see some of the general properties of the sine and cosine graphs.